Okay, so before we start looking at the Leaving Cert higher level algebra, we need to remind ourselves of a few of the important things from Junior Cert algebra. Now, over the next few videos, I'm going to sometimes dip into what you needed to know at Junior Cert and then build up to Leaving Cert level. I'm not going to do everything that was on the Junior Cert course because some of the easier things I assume that you're comfortable with. What I want to start here is to go through the different things that you have to be able to factorize at Junior Cert level. When I'm teaching Junior Certs, I always split factorising into 4 different sections. You need to be able to factorise the difference two squares, taking out the common term, factorising by grouping, and then by far the most important one is quadratics. In this video, I'm going to talk to you about the first 3, and then in the next video, we're going to talk about factorising quadratics. And then in the following video, we're going to talk about the only new type of factorising on the Leaving Cert higher level course. So I'm going to go through an example of each of these and then give you a number of questions that I want you to factorise. The first type we're going to look at is how to factorise the difference of two squares. So imagine you were just asked to factorise 49x squared minus 25y squared. In this case, this is the difference of two squares, because I know that the square root of 49 is 7 and the square root of x squared is x. So another way of writing the first term, instead of 49x squared, I could write it as 7x all to be squared. I also recognize that the square root of 25 is 5 and the square root of y squared is y. So if I multiply 5y by 5y, I would get 25y squared. So this is an example of the difference of two squares. It's two different terms squared and it's a difference. So this only applies if there's a minus between them. If there was a plus between these, I wouldn't be able to factorise it. There's nothing I could do there. But now that I've realised that I can get the square root of this and the square root of this, I'm just going to write this as double brackets. And at the start of each of the brackets, I'm going to put in the square root of the first term. So it's going to be a 7x here and a 7x here. At the end of each of the brackets, I'm going to put in the square root of the second term. So it's going to be a 5y and a 5y. And then one of them needs to be a plus and one of them needs to be a minus. Obviously, it doesn't matter which is which. But essentially the factors of 49x squared minus 25y squared are 7x plus 5y times 7x minus 5y. Remember that factorising is essentially the opposite of multiplying term. It's essentially the opposite of multiplying. If I multiplied 7x plus 5y by 7x minus 5y, I would end up back where I started. So basically the factorising is the opposite of multiplying out. Okay, the second type of factorising we're going to look at is factorising by taking out the common term. Now, often at third year level, a lot of students mix up factorising out what's common with the difference two squares, purely because both of them have two terms and often they can look very, very similar. Now, this example might not, but often you'll see that some of these ones can look very similar to the difference two squares. In this case, it's obviously not the difference two squares because there's a plus between the terms. I can't get the square root of 7 evenly and I can't get the square root of 14 evenly. In a case like this, all you can do is factorise out what's common. There's no letters in common because this is x squared, but this one is no variable. However, the number 7 will divide into both of them. So I can just factorise out 7. 7 into 7x squared will go x squared times. 7 into 14 will go twice. So that's all you can do with something like that. All you can do is factorise out what's common. Remember that if we multiply this out, we should end up back where we started. 7 by x squared is 7x squared. 7 by 2 gives me 14. So that's as far as I can take this one. The third type of factorising that we're going to do in this video is factorising by grouping. Now, the next type we're going to look at is quadratic equations, which we're going to look at in the next video. And there are a number of different ways of factorising quadratic equations. However, in my experience, the one that students find the easiest is the method where it's very, very similar to this. So I think it's important you're comfortable with this type of factorising before you look at the next video. Imagine I asked you to factorise 6x squared minus 2xz minus 3xy plus yz. Now in this case, it's clearly not type 1, it's clearly not the difference two squares. I can only have two terms for that. It's clearly not just factorising out what's common because there are terms here that don't have things in common, like 6x squared and yz. It wouldn't make sense for me to factorise out of every single term there. However, what I want to do this time is I want to factorise out what's common to the first two terms and factorise out what's common to the second two terms. So let's just work through that. Imagine if I just had 6x squared minus 2xz. If I want to factorize out what's common, the number that will divide into both is 2. The highest number that will divide into both is 2. And the variable they have in common is an x. I can factorize out 2x out of each of these terms. 2x into 6x squared, I would think of that as 2 into 6 goes 3 times, x into x squared goes x times. And then there's 2x into minus 2xz, 2 goes into minus 2, minus 1 times, the x divides into itself once, and then I've got a z. So I would just be left with minus z. Again, make sure you realise that if I multiply this out, I'll end up back where I started. 2x by 3x is 6x squared, 2x by minus z is minus 2xz. Now I need to factorise out what's common to the second two terms. Common to the second two terms in this case obviously is y. The highest number that will divide into both of them is 1. So I'm going to factorise out y. Now let's say that my instinct here was to factorise out a plus y. Imagine I decided to factorise out a plus y. Plus y into minus 3xy will go minus 3x times. Plus y into plus yz will go plus z times. Now this line makes sense because y by minus 3x is minus 3xy. Y by z is yz. Now that's fine, but at this stage you have to have the same thing in both brackets, which I don't. I have plus 3x minus z, and I have minus 3x plus z. I have the same terms but different signs. So I need to manipulate this somehow to change the signs in this bracket. In order to change the signs in this bracket, you change the sign of the variable or the term in front of it. I should have originally factorised out a minus y. And if I did, minus y into this would be plus 3x, minus y into this would be minus z. This still makes sense, this section, because minus y by plus 3x is minus 3xy, minus y by minus z is plus yz. So if you get a difficult one of those, you can manipulate it by changing the sign in the middle here. Now I have the same thing in both brackets, so I'm happy out. And my final answer will be the two factors. The first factor can be just the terms in front of the brackets. It can be 2x minus y. The second factor is just whatever is already in the brackets, which is 3x minus z. If you multiply 2x minus y by 3x minus z, you would end up back where you started with these four terms together. So that's the third type of factorising. It's nothing new, and I'm sure it's all things that you're relatively comfortable with. I'm going to give you a number of questions now that I want you to factorise, and they're all going to be of one of these three types. So in order to practice those types of factorising, I want you to factorise these 5 expressions. In each case, I want you to take it down, and I want you to work through it yourself. Pause the video now. When you have all your solutions, compare it to mine. So the first question was just a classic difference two squares. The square root of 9x squared is 3x to be squared. The square root of 100 is 10 to be squared. So I can just write this as 3x minus 10 times 3x plus 10. Now, as we go through this course, whenever we get the difference two squares, we're just going to skip straight from this line to this line. You don't need the line in the middle, so as we go through the rest of the course, I'm always just going to go straight from the first line to the factors. In part 2, you needed to recognise this as factorising out what's common. The number that will divide into both of these is 3. The largest number that can divide in is 3, and they both have an x. So if I factorise out x, 3x into 3x squared goes 1x times, and 3x into minus 12x goes minus 4 times. If I multiply 3x by x, I get 3x squared. 3x by minus 4 gives me minus 12x. So that's my final answer for part 2. In part 3, we had to factorise by grouping. In the first two terms, you factorised out 3y and you're left with 7x plus 1. In the second two terms, you should factorise out minus 1 and you're left with 7x plus 1. And your final answer then is 3y minus 1 times 7x plus 1. Part 4 was a little bit different and often one that catches out third years. In this case, we had 50x squared minus 32. We can't get the square root of 50 evenly, you can't get the square root of 32 evenly, so the only thing we can do really is take out what's common. In this case, what you needed to do was factorise out your 2. 2 into 50 is 25 and 2 into minus 32 is minus 16. Now inside the brackets we have 25x squared minus 16. Now the thing in the brackets is the difference two squares. Because the square root of 25x squared is 5x, the square root of 16 is 4. So I just have 5x minus 4 times 5x plus 4, and I just have my two outsiders. If I multiplied this out, I would end up back where I started with 50x squared minus 32. So this is my final answer for part 4. Part 5 was a little bit trickier. In this case, we had 6x squared minus 7. We had minus 21x plus 2x. The first two terms here, the only thing they have in common is 1. But it's not very useful for me to factorize out a 1 in this scenario. So I decided to rearrange them. Now I want you to be aware that it doesn't actually matter which way you rearrange them. There are two correct ways of doing it. I could have arranged the 3x squared and the minus 21x together, the minus 7 and the 2x together. I would have ended up with the same answer at the end either way. So if you did it differently to me, then that's fine. But you do need to get the same answer as me. What I decided to do was to group the first term and the last term. 6x squared plus 2x minus 7 minus 21x. Because I noticed that the thing that's common to the first two terms is 2x. And that if I factorize 2x out of the first two terms, I'm left with 3x plus 1. I factorized out minus 7 out of the second two terms, and I'm left with 1 plus 3x. Now clearly at this stage we have the same thing in both brackets. Okay, they're in a different order, but that doesn't matter. 2 plus 4 is the same thing as 4 plus 2. So 3x plus 1 is the same thing as 1 plus 3x. So all I have to do to get my final answer is to group 2x minus 7 as one bracket, and then 1 plus 3x as the other bracket. Now if you did it differently, then that's fine as long as you got the same answer. But be aware there is two different ways of grouping these and ended up with the same answer. So that's all I want to talk to you about in this video. Factorising is the cornerstone of so much of what we do over the rest of this course. Just you need to be really comfortable with all of this material, and especially what we're going to do in the next video, which is factorising quadratic equations.